Welcome to the first lesson of a brand new unit titled Polynomial and Rational Functions. The first topic is all about linear and quadratic functions and models. In the first lesson, we'll focus only on linear functions and models. We'll learn about polynomials and the degree of a polynomial. We'll create linear models using 2 points and a collection of points using the regression feature on a TID4. I'm Mr. Stark, and this is Polynomial and Rational Functions. Let's get started. Let's start with the word polynomials. It literally means many names, but nomials could also mean terms, like terms of endearment that people call each other. Maybe you've been called one before, like sugar, or honey, or muffin, pumpkin. So polynomial functions are functions with many terms. We'll use a's and x's to describe those terms. So here's the standard form of a polynomial function. F of x equals a sub n, x to the n, plus a sub n minus 1 times x to the n minus 1, plus however many other terms there are. And the last two terms are a sub 1, x to the 1, plus a sub 0, x to the 0. A sub n is called the leading coefficient. It's the coefficient of the x with the largest power. In fact, the largest power, which is n, is called the degree of the polynomial. All of the other a values are considered coefficients as well. Their subscripts correspond to the power of x. Speaking of the powers of x, polynomial functions don't have any fractional powers, which means there are no roots, and no negative powers. We'll study functions that have negative powers later on in this unit. Let's talk a little more about the degree of a polynomial. Like I mentioned, the highest power of the polynomial is called the degree. So for a constant function such as f of x equals a, or f of x equals 5, the degree of that polynomial function is 0, because really that polynomial function could be written as ax to the 0. X to the 0 is 1, therefore we have simply a. For a linear function such as f of x equals mx plus b, or we could call it ax plus b, the degree of that polynomial function is 1, because x is being raised to the 1 power, and that's the highest power of that function. We'll come back to linear functions in just a moment. The last polynomial function that I'll mention here is a quadratic function. The standard form for that is f of x equals ax squared plus bx plus c. A is the leading coefficient, and b, you might think, oh, maybe is that slope? It's definitely not. The degree of a quadratic function is 2, because that's the highest power of x. The last thing I want to do is think about what happens when you multiply two polynomials together. Let's say those two functions are quite generic, such as x to the n and x to the 1. When we multiply those two together, when we multiply bases with exponents, we add the exponents. We get x to the n plus 1. How does the degree change? In topic 3, we'll come back to this question and learn about polynomial functions of higher degree, such as cubics and quartics. But for now, let's focus on linear models. I mentioned that the model for a linear function is f of x equals mx plus b, but in practice, the best equation for a line is y minus y1 equals m times x minus x1. When we use this equation, we plug in numbers for x1, y1, and m. We leave x, and we leave y, and y is the same as f of x. Let's do an example. Let's say f of negative 1 is 2, and f of 2 is 3. Let's write the equation of the line that goes through those 2 points. You might be wondering, what are the 2 points? So just to be clear, the negative 1 is an x value, and the 2 is a y value. So our first point is negative 1 comma 2. And then we have 2 comma 3. Now we could find the slope between those 2 points, y2 minus y1 over x2 minus x1. Let's call the y value of 3 y2. So we have 3 minus 2 over 2 minus negative 1. In the numerator we have 1, and in the denominator we have 2 minus negative 1, which is a positive 3. Therefore, the slope between those 2 points is 1/3. We can also call that the average rate of change. Now let's use that slope and a point to write the equation of the line. We have y minus 2 equals 1/3 times x minus negative 1. And we could write that as y minus 2 equals 1/3 times x plus 1. We can use the other point to write the equation of the line as well. So we have y minus 3 equals 1/3 times x minus 2. Both of these equations represent the same line written in point-slope form. If we solve for y, we'll get the standard form, which is also known as slope-intercept. That equation is y equals 1/3 x plus 7/3. The slope is 1/3, and the y-intercept is 7/3. I think it's best to use point-slope form to write the equation of a line because you could always solve for y to get the slope-intercept form. The last thing I want to cover is the process of regression, creating a model based on data and using it to make projections or predictions. I introduced the process at the end of the Functions and Graphs unit, so if you want to see a calculator demo, check out Lesson 7b. My goal here, though, is just to show you the steps so that you can apply them to a linear model, a quadratic model, or any other model that we talk about in the future. Notice that the left column is just focused on how to plot data on TI-84 graphing calculators. First, we get set up by clearing all the equations in the graphing calculator. We go to y equals and clear everything out. Then we turn the plot on, and we do that by pressing second y equals. The other way to do it is in the y equals screen, and you just highlight whatever plot you want on and press enter. Then we go to stat edit to enter the data. Just like it says, we use L1 for x and L2 for y. Usually we need to change the window so that we could actually see the data or the scatter plot. So we do that by pressing window. But we can also press zoom stat, which is zoom 9, and it automatically changes the window for us. If you change the window manually, you have to press the graph button to see the scatter plot, but if you press zoom 9, it'll automatically graph the data. The most common errors are not turning the plot on or having a mismatch in the data. For example, entering 6 values for x and only 5 values for y. Notice that the right column is focused on how to find the regression line and correlation. After you enter your data and see the data on a graph, you press Stat and arrow right to Calc. You'll be given a list of options or models to choose from. One of them is LinReg, which is linear regression. That applies to a linear regression only. So in the future, if you do a quadratic regression, you choose quadratic, or cubic, or power, whatever. So you arrow down or press 4 for LinReg. When you entered your data, you most likely used list 1 and list 2. So just verify that you use those lists. The next thing you'll do is store the regression equation. You could do this by pressing alpha trace and choosing y1 or whatever function you want to use. But if you don't have this option, you either need to update your OS on the calculator or use the vars button and arrow right to yvars. Press enter a few times to calculate the regression model, and the screen will show you all the details about your model. So for LinReg, it's ax plus b, and it will tell you what the a value is and the b value is. This is also the screen that will show the correlation coefficient, which is defined by r. If you don't see this and you need to turn your diagnostic on, which is in the catalog. Just press second 0, look for diagnostic on, D, press enter on that, and enter again. I explained it in that video in Functions and Graphs Lesson 7b. Okay, then you go to y equals and you'll see the equation of your regression model, which should be the equation of a line. The best way to make predictions using the model is on the main screen. So press second mode, and then we'll use function notation to predict. Since we stored the regression equation in y1, press alpha trace, then choose y1 so that we could plug in values. We do that using parentheses. So y1, open parenthesis, the number you're plugging in, and then a close parenthesis. And that's it. We'll come back to this process a few times during this series. And that's the first lesson of the Polynomial and Rational Functions unit. I'm Mr. Stark. Join me next time for lesson 1b. Press that subscribe button, if you'd like to subscribe that is. Give me a thumbs up if you like the lesson. And if you have a question or comment, you can add it below. Thank you so much for watching. See you next time.